Hi, welcome to my video on type of discontinuity, and this one is on the asymptotic, or we could say asymptote. The asymptotic discontinuity is when there is a vertical asymptote. Each one-sided limit is unbounded. One limit is to positive infinity, the other limit is to negative infinity. And let's use this example of d of x equals 1 over x minus 3. So, if we let x minus 3 equal 0, that means x is 3. So, if we do the d of 3, x is 3, we have 3 minus 3. That's 1 over 0. And dividing by 0 in a fraction makes it undefined. So that means that we have the vertical asymptote VA is x equals 3. It's undefined. So x equals 3 right here, so we have a vertical asymptote. And because it's a vertical asymptote, there's no point that will lie on this line, so the graph does not pass through this line, x equals 3. Now, let's do a table of values to explain how we come up with. I did this before, but I'm just doing it again. Let's take 4. X is 4. So when x is 4, put a 4 in here. So I just write this function down here so we keep it close to the table of values. So when x is 4, this becomes a 1. 1 over 1 is 1. And as I go, I'm going close here now, so I'll make it 3.5. So I'll put 3.5 in here. 3.5 minus 3 is a half. The reciprocal of a half is 2. So if I go 3 1/4, 3 1/4 minus 3 is 1/4. Reciprocal of 1/4 is 4. So as I get closer and closer to 3, remember, 3 is undefined. So that means that the limit of the d of x as x approaches 3 on the right side, that limit is, and if I just draw a few points here, 4 gives me a 1, 3.5 gives me a 2, and 3 1/4 gives me a 4. So you can see it going up like this, up and up and up. It's getting, the closer I get, the higher this value of y will be. So that means it's going to positive infinity. Now let's do the table of values on the other side. We'll come in on this side from 2. So if we come in from 2, put a 2 in here. 2 minus 3 is negative 1. 1 divided by negative 1 is negative 1. Now we'll put 2.5. We'll get closer. So 2, 2.5. Let's see, put 2.5 here. 2.5 minus 3 is negative half. Reciprocal of a negative half is negative 2. And now we get 2 3/4 and 2 3/4. 2 3/4 subtract 3 is negative 1/4. Reciprocal of a negative 1/4 is negative 4. So you can see if we plot those points, 2 is negative 1. 2.5 is negative 2. 2 3/4 is negative 4. So you can see the graph is coming in like this. Remember, it will never go through this vertical asymptote. So that means, according to this one, the limit of the d of x as x approaches 3 on the negative side. Whoop, I said it approaches 3 on the positive. I said negative infinity. That's a positive infinity. My mistake. That's a positive. It's going upwards, going towards here. This is the one that's going down. It's going to negative infinity. Sorry about that little mistake there. And so that means the limit as x approaches 3, these two are not equal. So the limit at x approaches here, it does not exist. Now let's look at what happens as we move along here. Well, let's look at when as x approaches infinity. As x gets larger and larger and larger going along here, that means 1 over x minus 3. So as x goes to infinity, 1 over goes to 0. And as x approaches negative infinity, so that means, let's look back here, as x approaches infinity, the y, which is the 1 over x minus 3, approaches 0. So there it is. And as x approaches negative infinity, 1 over x minus 3 approaches 0 also. As x gets larger and larger and larger negative, this approaches 0. So that means that this has a horizontal asymptote at y equals 0. So as x goes to negative infinity, then the d of x goes to 0. So here it is here, but we'd like to find out what this point is. So let's let x equal 0. So the d of 0 equals 1 over 0 minus 3. So that's 1 over negative 3, which is negative 1/3. So 0 is negative 1/3. So this is the point right here, this point right here. This point is 0, negative 1/3. And as you can see, it's discontinuous. To the right, goes to positive infinity. To the left, it goes to negative infinity. So it's discontinuous at x equals negative 3, which is a vertical asymptote. So that means that this example, d of x, is asymptotic. Is y-m-p-t-o, is an asymptotic discontinuity. Take time to spell that out, just be careful. It's a discontinuities. So I've reviewed the 3 types of discontinuities. One was removable, second was a jump, and this was asymptotic. And this brings us to the end of this video. If you like my video, click the like button, click the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.